Welcome everybody to another lesson on Chapter 6. We're on Section 6.6 right now under the chapter of quadratic functions. And 6.6 in particular talks about quadratic functions using vertex form. Everything that we've done so far has been in standard form. And if you remember what standard form for quadratic functions is it's ax squared plus bx plus c equals 0. And we do a lot of things in standard form because one reason, I suppose, the biggest one, is that it's easiest to factor when it's in standard form. Another reason is that it's easy to do the quadratic formula because you know what A equals, what B equals, and what C equals. However, graphing in standard form is not very efficient. There's a lot of work that you have to do to get it into, or to find the axis of symmetry because it's a negative b over 2a and then substituting to find the vertex. It's not very quick. Vertex form to graph these quadratic functions much quicker. So that's going to be the objective for today, is going to be putting these standard quadratic equations into vertex form and then seeing how quickly we can graph those quadratic functions in vertex form. Another thing that we're going to see today is how valuable the technique of completing the square is, because at times, in order to put it into vertex form, we first have to complete the square. So that's going to be another application for learning how to complete the square. So as we go on to this slide, what vertex form is it's y equals a times the quantity x minus h quantity squared plus k. Now class, I don't want you to get too overwhelmed with this equation. I see how it could look intimidating at first, but it's really very easy to manipulate. If you guys remember from circles back in chapter 10 of geometry, you remember that the form for a circle was x minus h quantity squared plus y minus k quantity squared. That equals the radius squared. So if you remember, h and k was the center of our circle. So very similarly, h and k are going to be very significant. And I'm going to talk about that more in just one second. But if you also remember from circles, it was this minus sign did not come with it, such as if it was x minus 3 quantity squared plus y plus 4 quantity squared equals 25. This is for circles now. Remember how the center was at the opposite of a negative 3, or just the 3? This minus sign did not come with it. And then it was the opposite of this, which was a negative 4. There's the center of our circle, and then the radius was the square root of this, which was 5. So kind of tying this all back in together, math in every different math class, whether it be Algebra 2, Algebra 1, Geometry, Calculus, they all have a lot of similarities, so I'm trying to kind of work all this in to give you a further understanding. H and K are very significant. I will show you using the Sketchpad presentation. So as you can see, we have our form right here. Y equals a times the quantity x minus h quantity squared plus k. Now watch what happens to our a value. Our a value is at 1 right now. As you can see it right here. Okay, our a value is 1 unit long. What happens when we stretch our a value to be 2 units long? So right here, our a is 1. If you can there it is, a is 1. If we were to make this a 2, watch what happens to our parabola. It gets skinnier, doesn't it? What happens if a is 3? It gets skinnier yet. If a is 4, our parabola continues to get skinnier and skinnier the higher my a value is. If my a value is 9, which it is right now, I have a very skinny parabola. Watch what happens when it's 1 again. My a value is 1. Watch what happens when my a value is right around a half. If my a value is a half, it gets much wider. So as you have a smaller and smaller number, the wider and wider and wider your parabola is going to be. So that's our a value. Watch what happens to h. Right now, h is 4 units. Okay? What happens if it goes to 5? What happens to my parabola? Oh, it just shifts over 1 unit. My parabola keeps on shifting no matter where h is. If h is 10, my parabola's vertex is 10 units to the right. If my a value is, or if my h value, sorry, is 0, it's right on the y-axis. It is at 0. If my h value is at a -7, as you can see, it's -7 units to the left. So that is what h does to our parabola. And now k, h moves it left and right. K moves it. If you can see right now, k is this 3 units right here. What happens if I increase it 1 unit? It goes up. If I increase another unit, up, up, up. So as you can see, k moves my parabola up and down, h moves my parabola left and right, and a moves my value, or a changes my parabola skinnier and thicker. So, skinnier and wider maybe is what I should say. So going on to this one. The vertex is always at h for the x-coordinate and k for the y-coordinate. As you can see, my vertex right now is at, here's my vertex, and it is at right 5, 6, 7. It's right 7 and up 1, 2, 3, 4, 5, 6, 7. It's at 7, 7. So if you look, sure enough, 7, 7. There's my h and my k value. It's at 7, 7. Next thing, my axis of symmetry is always an x equals line because it's a vertical line, and it's x equals the x-coordinate. So x equals h. Whatever the x-coordinate is, that is what my axis of symmetry is. So in this case, on my sketchpad presentation, my x-coordinate is 7, so x, I can't write on here, so x equals 7 is my axis of symmetry. Picture a vertical line going right through 7. There's my axis of symmetry. Continuing with this, what do h and k do to the parabola? As we saw on the sketchpad presentation, h moves the parabola left or right. H is like the x-coordinate, and the x-axis goes from left to right, so h moves it from left to right. So then obviously what does k do? K is the y-coordinate, so consider the y-axis as going up and down. K moves the parabola up or down. And then what does a determine? First of all, I'll just write this down as a sentence and I'll explain it. A determines the shape and the direction of the parabola. A determines shape of parabola as well as the direction of parabola. There we are. So as far as A determining the direction, just the same as standard form. If A is positive, the parabola opens up. If A is negative, the parabola opens down. And as far as the shape, this is talking about how if it's skinny or if it's wider. The greater the A value, the skinnier the parabola is going to be. The lesser the A value, the wider the parabola is going to be. So just showing you one more time, the greater the A value, the skinnier it's going to be. Think about, maybe this is being the more you exercise. The more you exercise, the skinnier you're going to be. The less you exercise, the wider you're going to be. That might be a lame example, but that's one way that I remember it, I guess. So as your A value gets bigger, you're exercising more, you get a skinnier parabola. You exercise less and less and less and less and less, you get wider and wider and wider and wider. So that's a little bit on the terminology that we're going to be using. I guess I shouldn't say terminology, but more of the form and what those letters mean in vertex form.